Hello friends, welcome to this session. Just observe the slides. Will this ball stop? Unbalanced force is applied. Then what happens? Why the initial height and final height is same? Just think about it. Just observe the slide. After hitting, the girl is throwing opposite direction. What action takes place when they hit with each other? Just observe carefully. The man is pushing elephant. Freely swing. When he pushes to the other object, then they stops. Just observe and think about it. A person is pushing mass of 400 kg by applying force. Some troubleshoot will be produced, but same person is pushing or applying the force on 40 kg. There is the easiest way to apply the force. Just observe carefully. If an object is at rest and when you are applying the force, what action takes place? Observe carefully. Whenever the ball is throwing, the car is moving backward. Don't do this action, but just observe for our physics. The person on bike is hitting on the car and the accident event is happening. So friends, today we are discussing the Newton's laws of motion of your first unit, the first content, first article. Myself, Dr. Praveen Kumar R. Mirkute, Assistant Professor, Department of Physics, Yashwant Mahavidyalaya, Nanded. As already we know the Newton's laws of motion. There are three laws of motion. One by one we take it. While most people know what Newton's laws say, many people do not know what they mean or simply do not believe what they mean. Think about it. So these are the three Newton's laws of motion. First law, an object at rest will stay at rest and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. Second law of motion, force equals mass times acceleration. And third law of motion, for every action there is an equal and opposite reaction. Now recall all these the slides from one to the last one and relate with these three laws with their images or that slides. Think about it and relate with each other. First, first law of motion, that is the law of inertia. Newton's first law of motion is often stated as an object at rest tends to stay at rest and object in motion tends to stay in motion with the same speed and that same direction unless acted upon by an unbalanced force. The forces are balanced. If the forces are balanced, there are two ways we can arrange it: object at rest and object in motion. If the velocity is equal to 0 per meter per second when object at rest, when object in motion, velocity is not equal to 0 minute per second. But when the object at rest, acceleration is 0, that is the meter per second square. But when objects in motion, the acceleration is equal to 0 meter per second square. So that we can say the stays at rest and stays in motion. When it is stays at rest, velocity is 0 per meter per second, and when the stays in motion, object stays in motion, it's having the same velocity. In fact, it is the natural tendency of object to resist changes in their state of motion. This tendency is described as inertia. A more massive object has a greater tendency to resist changes in its state of motion. Inertia is the resistance an object has to change in its state of motion. The forces are said to be balanced when the net force on the objects are 0. That is when all the forces are added up, the result is 0. For example, when you are standing, the force of gravity is balanced by the force of floor holding you up. The forces are unbalanced when the net force is not 0. In tug of war, both teams apply forces. For a team to win, the forces must be unequal or unbalanced. You want the net force to be in your direction. So as already we see in the tug of war between the two teams, and when unbalanced force is there, then thread will be break up. So first law describing an object at rest will stay at rest and objects in the motion will stay in motion at constant velocity unless acted upon by an unbalanced force. These pumpkins will not move unless acted on by an unbalanced force. If you are not picking up, so the rest position is there. So inertia is the tendency of an object to resist the changes in its velocity, whether in motion or it motionless. So here is the example of airborne. Once airborne, unless acted on by an unbalanced force, the gravity and air fluid friction is there, it would never stop. Unless acted upon by an unbalanced force, this golf ball would sit on the tee forever. Why then do we observe every day objects in motion slowing down and becoming motionless, seemingly without an outside force? It is the force we sometimes cannot see, and that is the friction. Objects on Earth, unlike the friction, less space the moon travels through are under the influence of friction. What is the unbalanced force that acts on the object in motion? That is the friction. So there are four main types of friction: sliding friction, rolling friction, fluid friction, it may be or air or liquid, and static friction. For sliding friction, example is ice skating. Rolling friction, the bowling, when the bowler balls, the rolling friction is there. Fluid friction, air or water resistance, hydraulic pumps are there. Static friction, that is the initial friction when moving in objects. The book is on the slide across the table. So slide a book across a table and watch it. Slide to rest position. The books comes to a rest because of the presence of a force. That force being the force of friction, which brings the books to at a rest position. In the absence of force of friction, the book would continue in motion with the same speed and direction forever, or at least to the end of the tabletop. This is the examples of Newton's first law and you, what action takes place. Don't let this be you. Wear seat belts, because if you are not wearing the seat belts, you jump or you are throwing out of the car and accident takes place. Because of inertia, objects, including you, resist the changes in their motion when the car going 18 km per hour and is stopped by the brick wall. Your body keeps moving at 80 meters per hour. Another laws of motion, that is the Newton's second law of motion. As stated in the first law, the presence of unbalanced force will accelerate an object, changing either its speed, its direction, or both its speed and direction. This is the example of ball. Just observe it. Newton's second law of motion pertains to the behavior of objects for which all existing forces are not balanced. The second law states that the acceleration of an object is dependent upon two variables: the net force acting upon the objects and the mass of the object. The acceleration is always in the same direction as the net force. When the forces are unbalanced, the acceleration is not equal to zero. It depends directly on the net force and depends inversely on object's mass. So mathematically, acceleration A is equal to net force, which is applied on the object, divided by the mass of an object, and commonly it is written as F net is equal to m into A. Do not use this value of merely any force in the above equation. It is the net force which is related to the acceleration. The net force is the sum of all the forces acting of an object. So here the net force of an object is equal to the product of its mass and acceleration, or we can write F is equal to m into A. When the mass is in kilograms and acceleration is in meter per second, then unit of force is Newton. 1 Newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second per second. Here F is equal to m into A. How much force is needed to accelerate a 14,000 kilometer car 2 meters per second per second? This is the problem and we are solving it. That is, write the formula, that is F is equal to m into A. Fill the given numbers and units. F is equal to, mass is 1400 kilogram or 1400 kilogram. Car meters 2 per second per second. So A is the 2 meters per second per second. After solving it, 2800 kilogram meters per second, or we can write 2800 N. These are some example. Net forces is equal to mass, kilograms and acceleration. Just observe it. Newton's second law proves that different masses accelerate to the earth at the same rate but with different forces. Here we are taking the two examples. M is equal to 10 kg and M is equal to 1 kg. Here it is, the mass is having bigger comparative to this. The force of gravitational force is applied directed to downwards. Again here the force of gravitation. So the 98 N and 9.8 N. Substitute the value. A is equal to force, that is the 98 N divided by the mass 10 kg, we get 9.8 meter per second square. Similarly here we get 9.8 meter second square. Same. Here what happens, 9.28 Newton and 1 kg. So the 9.8 meter per second square. Here we know that the objects with different masses accelerate to the ground at the same rate. However, because of the second law, we know that they don't hit the ground with the same force. When apple hitting on the Newtons, the Fg is equal to G m1 m2 by r square. The force is equal to, the G is the gravitational constant. The first object is having mass 1, second object is having mass 2, divided by the distance between the two objects. So the Newton's law of gravitation will be generated, that is the G is equal to mm by r square. The gravitational force is directly proportional to the product of their masses and inversely to the square of the distance between them. Here some examples. Check your understanding, how much you understand. So these some problems are there. Just solve it, and after solving put it on Google Classroom, so we can assess betterly. Same problem, but here I am solving. The first problem, what acceleration will result when a 12 Newton net force applied to a 3 kg object, a 6 kg object? So the answer is 12N is equal to 3 kg into 4 meter per second per second. Similarly, the three problems are there where we are calculating the 9800N, 6060N and 3.2 or 16N is there. So these are the examples with their solutions. What is the force? Force is the push or pull that causes change in the motion of an object. The first example, here there is a force of attraction between the two objects, moon and earth, is directly proportional to their product of their masses and inversely proportional to the square of the distance between them. So there is the force The earth is pulling, so they are bounded with each other. The gravity here, the force between the two objects. The static electricity, when your comb is in motion, through your hairs, the charges are depositing on the combs and we get the static electricity. And when we are using the table lamp, the force of electrons due to the electricity will be there. The magnetism, force of the field between the two. Then the friction takes place here, and the friction when the force opposing the motions. So the frictions takes place. Then third law of motion. A force is a push or pull upon an object. This implies there must be two objects, one being be pushed and one doing the pushing. Be careful. One being pushed and one doing the pushing. Thus, force results from interaction between the objects. According to the Newton's third law, whenever objects interact with each other, they exert a force upon each other. These two forces, the objects exerts on each other and are called as action and reaction. So we can easily define the Newton's third law. For every action, there is an equal and opposite reaction. The statement means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equal the size of the force on the second object. The direction of the force on first object is opposite to the direction of force on the second object. Force always comes in pairs, and that is equal and opposite. Action, reaction, forces, pairs. So according to third law of motion, for every action there is an equal and opposite reaction. This law describes the relation between two forces in an interaction. One force is called as action force, while the other is called as a reaction force. And neither force exists without the other. They are equal in strength and opposite in direction. They occur at the same time and simultaneously. Here is the example. When the person is jumped from edge of the boat on the surface or on the platform, so the boat will move backward direction. Look at the wall pushing on me. When you push on the wall pushes on you. So this is the force and interaction. According to Newton's, whenever objects A and B interact with each other, they exert a force upon each other. When you sit in the chair, your body exerts a downward force on the chair, and the chair exerts an upward force on your body. Here is the best example. There are two forces resulting from this interaction. A force on the chair and force on your body. These two forces called action and reaction forces. Here, consider the propulsion of a fish through the water. A fish uses its fins to push water backward. In turn, the water reacts by pushing the fish forwards, propelling the fish through the water. The size of the force on the water equals the size of the force on the fish. The direction of the force on the water backwards is opposite the direction of the force on the fish forwards. This is the example of Newton's third law in nature. Again, the flying gracefully through the air. Bird depends upon the Newton's third law of motion. As the birds push down on the air with their wings, the air pushes their wings up and gives them lift. Consider the flying motion of birds. The bird flies use of wings. The wings bird push air downwards. In turn, the air reacts, pushing the bird upwards. The size of the force on the air equals the size of the force on the bird. The direction of the force on the air downwards is opposite the direction of the force on the bird upwards. Here the action reaction takes place in the form of force pairs, make it is possible for birds to fly. Just observe this scene. Here the baseball forces the bat to the left, an action takes place. The bat forces the ball to the right, the reaction takes place. Here the motion of the car on the way of school. A car is equipped with wheels which spin backwards. As the wheels spin backwards, they grip the road and push the road backwards. The reaction of rocket is an application of the third law of motion. Various fuels are burned in the engine, producing the hot gases. The hot gases pushes against the inside tube of the rocket and escape out the bottom of the tube. As the gases move downward, the rocket moves in the opposite direction. I hope you understand the first content, that is the Newton's law of motion. Thank you for watching this video. Please subscribe the channel and put your comments in YouTube channel. Thank you very much.